Welcome back to the Explainer Study Buddy. So today we're making a pretty massive leap. Up until now, if you've been following along with Python, you've probably learned how to create some variables, maybe do some basic math, and use a few logical operators to make simple decisions. But today, we're transitioning from just writing basic, isolated lines of syntax to actually designing program behavior. We're going to explore how a program should act, react, and sustain itself over time. It's a real game changer.
Okay, let's dive right into this by asking a very simple question. Would you write the exact same piece of code thousands of times? Seriously, imagine you have to process a list of 1,000 customers. Are you going to literally sit there and type out print customer 1, print customer 2, all the way to 1,000? No way! That would be incredibly tedious, highly prone to human error, and frankly, just a terrible use of your time. And that right there sets up the ultimate pain point in programming: manual repetition.
I mean, think about it. Think about a banking system that has to process thousands of financial transactions. Or imagine a hospital system checking patient records, or an e-commerce platform constantly monitoring its inventory levels. In every single one of these situations, the computer needs to perform an action, check something, perform another action, and then check again. Manual coding for this is literally impossible. That is exactly why loops are an absolutely essential tool in your toolkit.
So, here's our roadmap for today's explainer. We're going to take this step by step. First, the power of repetition. Second, updating your variables. Third, the core loop pattern. Fourth, avoiding infinite loops. Fifth, small details, big impact. And finally, number 6, thinking like an analyst.
Let's get right into section 1, the power of repetition. Why loops matter.
You see, programming isn't primarily about just writing a ton of code. It's really about creating efficient instructions that allow a computer to perform repetitive tasks accurately. And the fundamental instruction a while loop gives to Python is this: keep doing this task while a particular condition is true. It's the mechanism that takes all the heavy lifting off your shoulders and puts it onto the machine. It allows the computer to do what it does best, which is perform tasks accurately and consistently at lightning speed, as long as you give it the right rules, of course. Moving on to section 2, updating your variables, changing values over time. So before we can even jump into the loop itself, there is a core prerequisite we absolutely have to understand. We need to know how to update variables so they can actually change from one iteration to the next. Now, assigning a variable, like saying x equals 0, is easy enough. But what about x equals x plus 1? At first glance, looking at that mathematically, it kind of seems impossible, right? How can x equal x plus 1? Well, remember, in Python, the equal sign isn't about mathematical equivalence, it's an assignment. Python brilliantly evaluates the right side of the equation first. It takes the current value of x, which is 0, adds 1 to it, and then stores that new result, a 1, right back into the variable x. If we run it again, it takes the current value of 1, adds 1, and stores 2. This concept is incredibly important because loops depend entirely on variables changing over time. Which brings us to a crucial point, the golden rule. Initialize your variable before attempting to update it. You literally cannot write x equals x plus 1 if x has never been defined. Why? Because Python needs to know the current value of x before it can do the math on the right side of the equation. You always have to set a starting line before you tell Python to start running. All right, section 3, the core loop pattern, the engine of repetition. Now that we know how to update our variables, we can look at the actual mechanics of the while loop, which is built on a very specific, highly reliable pattern. A while loop is a control structure that lets Python repeat a block of code while a condition is true. Just think of the word while in everyday language. If I tell you, while the traffic light is green, keep driving, there is a super clear condition there. The light is green. As long as that condition evaluates to true, you execute the action. You keep driving. Once the light turns red, the condition becomes false, and you stop. Well, a Python while loop works with exactly the same basic logic. And this brings us to the absolute foundation of every single while loop you will ever write. It's a simple 5-step pattern. Step 1, initialize your variable. Step 2, check the condition. Is it true? Step 3, if yes, execute the code. Step 4, update the variable. And step 5, repeat. Meaning, go right back to step 2 and check the condition again. Initialize, check, execute, update, repeat. Burn this pattern into your memory for sure. Let's see how these 5 steps translate into real Python code to process, say, 100 transactions cleanly and efficiently. First, transaction equals 1. We initialize. Then, while transaction is less than or equal to 100. We check the condition. Next, print transaction. We execute the action. And finally, transaction plus equals 1, which is just a handy shorthand for transaction equals transaction plus 1. We update the variable. That update step is literally the engine that pushes the program forward, transaction by transaction, until it hits 101, the condition becomes false, and the loop naturally stops.
Which leads us nicely to section 4, avoiding infinite loops, the danger of stagnation. So, what happens when we forget one of those critical 5 steps, specifically the update step? Well, if you forget to update your variable, the value never changes. And if it never changes, the condition never becomes false. Your program will just run forever in an infinite loop until it completely freezes your system and ruins your entire afternoon. Actually, to prevent this, I want you to ask yourself these 2 powerful debugging questions every single time you write a loop. What is changing, and will that change eventually make my condition false? If you can't confidently answer those, you've got a bug waiting to happen.
Section 5, small details, big impact. Precision in conditions.
We really need to focus on how tiny, seemingly insignificant logical differences in your loop's condition can drastically alter your actual business logic. Consider the difference between while n is less than 5 and while n is less than or equal to 5. That is literally a single keystroke of difference, just adding an equal sign. But the impact? Massive. The first condition is going to stop before processing the number 5, while the second one allows 5 to be processed. In a real-world scenario, that tiny difference can entirely mess up financial calculations, inventory limits, or customer records. You've got to develop the habit of reading your conditions with extreme precision.
And our final section, section 6, thinking like an analyst, designing real processes.
How do we move from just memorizing Python syntax to truly understanding program logic? Our source material emphasizes a fantastic point here. You have to experiment. Don't just stare at the code, interact with it. Run it, break it on purpose, fix it, and change the conditions around. What happens if you count downward instead of upward? What happens if you add 2 instead of 1 each time? This active process of breaking and fixing is how real learning happens. It's how you transition from being just a reader of code to a true master of it. To really prove to yourself that you've mastered this, use this 5-point mastery checklist. By the end of this lesson, you should be able to look at any while loop and confidently point out exactly where it initialized, what the controlling condition is, what the execution action is, how the update process works, and logically why it will eventually stop. If you can clearly explain those 5 things, you aren't just using a while loop. You truly understand it inside and out. And this leaves us with our final thought for today's explainer. Are you simply telling a computer what to do, or are you designing a process? You see, programming becomes infinitely more fascinating when you realize you are the architect here. You decide where the process begins, what controls it, what changes along the way, and when it definitively ends. You're building real-world automation. So as you go practice your while loops, keep this analyst mindset front and center. Run the examples, always ask why, and design your processes with purpose. Until next time, keep experimenting.